In this video, we're going to cover our clustering modeling workflow. The goal of this workflow is to perform our clustering using k-means clustering. To do this, we'll first start with our vector assembler, and then we'll use a standard scaler. This is an easy way to boost model performance of different clustering algorithms. Next, we'll use our k-means node using Spark ML. Finally, we will use our Spark predict node to actually create the cluster labels, and then we will drop the unnecessary columns. At this point, we are done with modeling. However, this will be difficult to interpret if we don't add context to our clusters. To do this, we will using the join using SQL node and bring in our clean invoice data. This will provide context to the clusters and give us the ability to analyze the clusters directly in the same workflow. The first thing we want to look at is the distribution of our customers or stores by cluster. Next, we will be plotting various features of each cluster. This will help us look at them in a more visual way, which can be easier to read and interpret for those who are not familiar with the data. Now let's take a look at the output of this workflow. Here in the execution page, the first thing we have is the cluster distribution in a pie chart. We can see that a majority of our customers are in cluster 0 and cluster 2, with only 8.6% of our customers in cluster 1. So that may be a unique place and a good way to start our analysis. Next, we will take a look at our cluster profiles. This shows us the average values of each column for each cluster. However, this can be hard to read and difficult to understand for those who are not familiar with the data. So let's take a look at these same values in some graphs. The first graph we have is the average monthly purchases by each cluster. Here we can see that the 8.6% that exist within cluster 1 by far have the highest number of average monthly purchases. We see the same pattern show up in the average number of invoices per cluster. We can see that the stores that exist within cluster 1 have easily more than those that exist within cluster 0 and cluster 2. Here we have the average count of invoices per cluster. This deals not with the value as we did in the previous graphs, but simply the number of invoices sent in by each cluster. Interestingly, those stores that have the highest purchasing values in cluster 1 do not have the average highest total number of invoices, or the average total number of invoices. Those stores exist within cluster 2. So cluster 2 stores are very high in terms of their concentration by invoice. Next, we have the average count or the total unique products within each cluster, or their cluster invoices. Here we can see that cluster 2 has a very small number of average total unique products within their invoices. This tells us that cluster 2 stores are stores that provide a high number of invoices, but only carry a few number of products or only make sales on a certain number of products. Finally, we have the data with the cluster IDs. Now that we have identified some general patterns, we can now sift through this data with our cluster IDs already added to the dataset. Thank you for listening.